During the latter part of the 19th century, experimenters noted a glowing beam emitting from the negative electrode of a gas discharge tube. The negative electrode is known as the cathode, so they dubbed the emissions cathode rays. J. Thomson noted that electric or magnetic fields deflected the cathode rays, so he believed they were tiny negatively charged particles. To find out more about the rays, he constructed a cathode ray tube with plates to produce an electric field that deflected the cathode rays in one direction, and coils to produce a magnetic field that deflected them in another direction. By varying the strength of the electric field in the tube, Thomson was able to adjust the beam to the point that its path was undeflected. Because he knew the force exerted on the cathode ray particles by the electric field, as well as the force exerted on the particles by the magnetic field, and because he knew those forces were equal when the beam in the tube remained undeflected, he was able to determine the charge-to-mass ratio of a cathode ray particle. This particle is now known as the electron, and Thomson is credited with its discovery. Later, Robert Millikan determined the mass of an electron with his oil drop experiment. Millikan sprayed tiny drops of electrically charged mineral oil in an electric field. He then adjusted the electric field such that the force from gravity on a drop was just balanced by the force exerted on it by the electric field. From this information, he was able to determine the charge on the oil drop, which he discovered was always an integral multiple of some smallest charge. He concluded this smallest charge was that of an electron, and using the previously determined mass-to-charge ratio of the electron, he determined the mass of the electron.